This is a Z80 processor. Now this was pretty popular back in the 80s, 90s and a little bit before that, and it was used in all sorts of home computers and various other bits of equipment. So if you wanted to have a microcontroller, or the equivalent of, back when this came out, you'd put this in a circuit with some RAM and an EEPROM. That's an EEPROM, and that will give you, with some latches for I/O, that will give you a sort of microcontroller equivalent. Now I've always wanted to make a Z80 sort of small computer, but one of the things that's always stopped me is this. This is the EEPROM. Now, unlike Flash that you get on Arduinos and microcontrollers these days, which is really easy to use, you just program it. I mean, that's a simple button press or command to just upload your code onto the Flash, and couldn't be simpler really. But these things are much harder to program. For a start, some of them, at least to start off with, needed high voltages, which means you needed a high voltage power supply, higher than the 5 volts that runs the Z80, and you needed to have an algorithm to program the chip. Now when you're programming these chips, you can't actually read from them, so you erase them completely and then you program your code in there. So it's not like a Flash chip where you can program sectors and carry on executing some other way, either out of RAM or out of the Flash chip itself. This thing, you erase it. And another difficulty, erasing takes minutes, because this window here, you shine UV light in there and the chip slowly sort of degrades and erases itself. It takes ages, and you need a bit of kit to do that. So it's not really in-circuit programming, it's more sort of prise it out with a screwdriver, put it in a box, erase it, maybe then plug it into another box which programs it. You can do in-circuit programming if you're really careful, but it's a lot of sort of mucking about. So you do get microcontroller or microprocessor trainers, and one of the ones that was pretty well known is this. This is a microprocessor 1F, MP1F I believe, and if I just power that on, you can see it comes up. It's got a nice vacuum fluorescent display there. Just shade the light a bit. Let's wash it out a bit. And this is sort of a way around the problem of having these things, the EEPROMs. You can see you've got the processor here, EEPROMs, bit of RAM, and here you've got some 8255 I/O chips. So they provide I/O, and what you've got here is essentially a microcontroller. Now these aren't actually Z80 I/O chips, they're 8080, the 8255, but the Z80 has its own I/O chips in its own family. So here you've got a board which is pre-programmed with the program in there, and what that does is it brings up a monitor. So here you can examine memory on the keyboard, so that's what's at 0, and you can move around it and you can type code in and you can execute it. That's the reset button. But the actual program that you're running on here is always the monitor program, and you've got no way of saving the program. So the only way you'd be able to do it would be through cassette, so you'd actually write it to a cassette. So I got a bit fed up with this, programming these EEPROMs, and I was thinking one day I'd like to build a Z80 single board computer, and I thought, well, if we put a flash chip down, how do you program that? because when the flash chip is on the board initially, it's blank, so you need to put a program in there. And then I thought, well, you could just attach an Arduino to it and use that to program the chip. So after a lot more work, I came up with this. So this is a Z80 single board computer. It's obviously got a shield connector there, but on the back, I'll pull it out, you've got an Arduino Mega. So the Mega plugs in here and it's got various control lines. Now I use the Mega because it's got a lot of GPIO lines, and in order to program the flash chip, which is here, you do need quite a few lines because you need the address and data bus, and immediately that's 24 lines, but the Mega is easily able to handle that. It's got over 50. So with the address data lines and all the control lines, you can actually get in there, and with a suitable program on the Mega you can program this flash chip. Now once I'd done that, I realised that in order to program the flash chip you really need to attach to practically all the signals on the Z80 bus. So there's a bus between the Z80 and the I/O chips and the RAM chip and the flash and any other hardware that is in the system. Now once you've done that and you've got an Arduino sitting on the bus, you sort of, if you go one step further, you can actually take over the entire bus and run the hardware from the Mega. So the Mega can access all the RAM and all the hardware on this system. There's a mechanism in the Z80 where you can release the bus, so the processor just releases it and sits there with high impedance on its pins, and other hardware can come in and access whatever is on the bus. That's used for coprocessors and DMAs and things like that to actually do burst moves in memory and things. But in this case, what you can do is you can take over the bus. So you grab the bus, the Z80 processor becomes completely silent on the bus, and the Mega can come in and program the flash chip. So now you've got a way of programming the flash chip which is completely in circuit and doesn't need any extra hardware. You can do it just on this board, and while you're programming the flash chip the Z80 is quiet. Now I then thought, well, as you've got the Mega on the bus, once you start the program running on the Z80, there's nothing stopping the Mega from monitoring the bus apart from the speed that it runs at. This runs at 4 meg. There's a little oscillator here which is a bit fast for the Mega to actually do anything, but then I thought, well, you could arrange it so that the Mega can supply the clock, and once the Mega supplies the clock it can run at whatever rate it's happy at. You've then got full monitoring of the bus, so you've got all the address and data bus of the Z80 that can be monitored by the Mega. So you can actually run the code that is in flash or RAM. You can run that code using the Mega to clock it and the Mega to monitor it, and you end up with a full bus analyzer and sort of in-circuit emulator as well. You can look at every single signal on the bus using the Mega on your PC over a serial link and watch the code execute, and you can see every single edge on the bus. So every half clock cycle you can watch, and you can watch the Z80 do all sorts of things that you don't normally see. So on the microprocessor you can run code, but basically you don't see any of it execute. You just see the results of it in memory or on the display. Here you can actually see instructions execute. You can see all the memory accesses, you can see the instruction being fetched, you can see all the operands being fetched if they're fetched from memory, you can see the results being written out, and you can see things that you don't normally see, like the refresh cycles for dynamic RAM that the Z80's got. You can watch that go on between instructions. So then I thought, well, what sort of I/O do I put on here? And there's a lot of different things. I could have just put an 8-bit port and flashed an LED, but then I thought, well, why don't I just put shields in there? So you need more I/O to do that, and that actually causes the Mega to run out of GPIO lines. So I've got a couple of Z80 PIOs here, which are parallel I/O ports, and they've got 2 8-bit ports each, so there's 32 lines of I/O there, and that's enough to drive the digital lines for the shield. I've also put an A to D chip here, so there is an A to D chip, so you can read analog channels as well. There's a 3.3 volt regulator there. This is a 5 volt Z80 Arduino, if you like, when you've got shields plugged in, but if there's any circuitry that requires 3.3 volts, there is a 3.3 volt regulator there. So you can plug that in and then power it up. Now there's 2, power comes from the USB here and here. Now when you're powering it with the Mega attached, you power through the Mega. When you're powering it through the other connector, this PCB becomes a single board computer. So I've previously programmed, using the Arduino, I've programmed a short test program in here, and then when you power it up, you can see that on the LCD it's actually saying Z80 shield, and the Z has been changed to a different character because that is looking at what key is pressed. So when you press different keys, different characters appear in the first position. And this is now a single board computer, so you could program it up with flash and have it running whatever program you want with whatever shield plugged in here. So you can make your own shields, or you can, in this case we got the LCD and switch, push button switch shield. So that is a single board computer with the Mega removed. When the Mega's attached, there's a bit of software that you can run, and you can examine all sorts of signals. Every signal on the bus you can see, and you can clock it for half cycles, so that's every edge on the clock signal, and you can see what happens. I won't go into that here, it's on my blog. I'll put a link to that down in the description. So it does run a lot slower when you're running on the Mega. Instead of running as it is now at about 4 megahertz, it runs at about something around 80 hertz, something that sort of order, which is pretty slow. But I mean, if you don't really want to run anything that you're running and you're trying to run fast, you'd run it like that as a single board computer. You aren't going to be able to keep up with it running at 80 hertz anyway. You really want to run it about 1/100th of a hertz in order to examine the signals and see what's going on with the bus. Let's pull that out. So at the moment, the only shield I've actually got working is the LCD and push button one. But on here, there's 512k of flash, which is a lot. It's more than the Mega's got. There's quite a lot of I/O because you've got the PIOs here, and they allow you to have quite a few lines of GPIO, so you've got enough for driving a shield. There's also some auxiliary signals here. I put a timer counter chip in there for doing timing, so if you want to generate PWM and so on, you could do it through here. That's not wired into the Arduino shield because there's no switches. You don't switch the line to be a PWM line or a GPIO in hardware. Here you have to wire the PWM here, so you could control servos if you wanted to down here. The RAM, there's 32k of RAM, which again that's quite a lot. That's more than a lot of the Arduinos have. So there's masses of flash, and that's bank switched, so there's some hardware here that lets you switch in different pages, so you can have 512k of code in this thing. You'll need a little bit of overhead for a little bit of code that lets you switch between the pages, which is in every page, and you lose a little bit, but that's only a few bytes. So yeah, it's a single board computer, or a complete sort of logic analyzer if you like. the Mega becomes a logic analyzer sitting on the bus. It can also drive the bus. You can also, if you want to, you can emulate the hardware that's on the bus. So that's where the Z80 executes, but the Mega provides data at certain addresses on the bus, the I/O or the memory bus. It handles both. So you can emulate hardware on the bus if you want to when you're running at the emulated speed. Obviously when you run as a single board computer that doesn't exist and the hardware would disappear. But if you wanted to, you could put the code in the memory of the Mega, and then that gets presented on the bus as you emulate the code and step through it. Reset button there, so you can reset it when it's a single board computer. There's a few things that are tricky. So on the microprocessor, in the monitor program, when you want to see what's in the registers, the code that you're running, the monitor program, will go and grab the registers and then let you view them somehow through a menu option or whatever. On here, as you're emulating the code, because the Mega isn't the Z80, so if you think of the Mega as being the monitor program in the microprocessor, then it will be showing you what's on the bus, but the only way that it can see things like register contents is by getting those out onto a bus. So the way I've done that is to arrange for a small bit of code, Z80 code, to be executed by the Mega in between every instruction of the Z80. So as the Z80 executes, it'll execute one instruction, and then if you want to see what is in the registers, the Mega then executes a small program which presents all the registers out on the bus, captures the values, and then puts the internal state of the Z80 back to where it was. So the program counter and all the register contents are put back to the state they're in after that instruction that just executed finished. So you execute an instruction, and you run this other code which enables you to grab all the registers, and then the state is put back as if nothing had happened, and then you execute the next instruction. And that means you can go in and grab the registers in between instructions, and it doesn't matter what the instruction is. You can go in, grab them, display them on a little window, and then just do the next instruction. So that was a tricky bit. I mean, in a monitor like the microprocessor, that's quite an easy thing to do, but here it wasn't. So yeah, there's more information on the blog, and the PCBs on Dirty PCBs. There's a couple of wire links needed on this revision, and I might do another one. There's a few things that would be nice to change, but this does work. Version 2. Right. So there might be a 2.1, but I don't know. If you put the flash chip in a socket, then you can use this as a flash chip programmer. So you could then program flash chips with a monitor program like the microprocessor, and then put that on another single board computer and execute your code on that single board computer, which could be one of these or a smaller cut down version that doesn't have the shield footprint there. You can then execute your code on that other computer and never actually have a Mega plugged into that one. So you could use it as a program if you put a socket there. I haven't, I've soldered it on here. So yeah, that was quite fun, and I've now made myself a Z80 computer. So I've done it after, well, decades probably.